Okay, in this presentation we're going to look at logistic regression. So I'm just going to sort of have this running in the background. It just takes a second, but it's not that quick. And so I'll just go over to my main slide set there. So I'm using Azure Notebooks, and I'm going to use that to show off logistic regression. Okay. So logistic regression is useful for when you're trying to model a binary outcome, predict a binary outcome, yes or no, true or false, 1 or 0. Okay. And you were trying to base your predictions on a set of continuous predictor variables. Okay. So the general structure is as follows: like logistic regression, where f is a binary factor. Now that's in this case, I mean f, as I probably shouldn't have done that really, but f is a factor rather than false, and it is a f for factor in this case. It's a binary factor. Well, it should be a factor also, so it's not that such a bad idea. Anyway, we have x1, x2, x3 are continuous variables. Okay, continuous predictors. So what we're trying to do here is predict this binary factor by x1, x2, and x3. Okay, and they're all contained in this data set called my data. For this particular example, we'll have see one called SA Heart shortly. Okay, but whatever the data set that they are contained in, the data frame, they should all be columns of a data frame. Okay, so it's a binomial. Means binary logistic regression. Binomial means essentially, I mean, you might have heard of the binomial distribution and so on. Just actually sort of read that as maybe binary, as in binary logistic, okay, or take it as that as the meaning in this case. So family equals binomial. That is what I have highlighted there. Is I believe that is the link function. Okay, which is very important in fitting GLMs. Now, GLMs are generalized linear models. That is the name of the command. Okay, GLM. Okay, and we're going to give that model that we fit. We're going to call it fit. You can call it my model, but just for the sake of brevity and for the sake of space, I'll call it fit, as short for fitted model. Okay, so some useful commands when you're working with logistic regression is, first off, you want to have a look at the results. So you might look at summary of fit, summary fit in brackets. Okay. You might be interested in the 95% confidence interval for the coefficients. Okay. Are you the exponentiation of those coefficients, exp of coef of fit? Okay. And if you wonder what that means, that is equivalent. That's essentially the odds ratios. Okay, so if you're familiar with SPSS and you're looking around for odds ratios because you're familiar with that, that's how you would sort of go about it in R. Okay, and a 95% confidence interval for those exponentiation coefficients. So essentially the confidence intervals for the odds ratios. Okay, now and also there's a couple of other interesting things, like there's predict. And this is actually the predicted value from the predicted values from the data used to fit the model. Okay. I'm actually going to sort of do two different things with that later on, where we can actually look at the model or predictions based on the model that we use to fit the data, okay, to calculate residuals, and we'll actually sort of use the predict function to make new predictions, okay, or from unseen data. Finally, residuals. I feel a bit conflicted. Just for the sake of brevity, I'm going to sort of skim past this. But just to sort of say that residuals are a very overlooked part of the model fitting process. So I strongly recommend actually just learning more about residuals. Okay, it's very interesting stuff. Now, so what we're going to do here is load the South African heart disease dataset from LMStatLearn, our package, and create training and test datasets. Okay, so this is a little bit of code that we would use. Now, do we have it ready? So essentially, I just had that sort of warming up in the background because, unfortunately, the video software can be very hard going, and sometimes that can take a lot of time to run. Essentially, this is Azure Notebooks, and I'm using R, and I just run that bit of code there in the cloud, okay, and the data set is there ready to go, okay. So let's have a look at it. So I'm just gonna I could show the whole lot, but essentially what I want to do here is actually just look at the tail. The last 6 cases. So seemingly we have 463 cases, SBP. I think that means systolic blood pressure. Okay. Tobacco, LDL. These are sort of a lot of related to your medical history, including age and so on, that sort of stuff. Okay. Now the variable at the end, CHD, means coronary heart disease. So that is, and you might notice there that it's a load of zeros and ones. Okay. So that is quite important. We can get the summary of it there as well. So I'm just going to slightly rewrite that as summary. Because something you should do, actually, and it's important to do this, is that you might get missing data converted from one type to another. So it should only be ones and zeros there. Okay, so the min is 0 and the max is 1. Okay, now that you can ignore. Okay, just actually, it is not here as a factor. It's not listed here as a factor, so we'll just sort of talk about that later on. Okay, it actually here is as written here, it's a numeric variable. Okay, CHD. Okay, now there's 2 things I'm going to do. So I'm going to do the simple way first. It asks us to create a training data set and a test data set. So essentially what we're going to do is split the data in 2. Okay, now what I'm going to do here shortly is I'm going to show you how to do this a sort of more advanced way. But if you're a beginner, let's just use some basic stuff and we'll go with that for the time being. So n row is how you might determine the number of rows, okay, in a data frame. Okay, so there's 462. Okay, did we see that before? We did actually. I just realized I got rid of it. Okay, and suppose we want to sample 350 values, okay, from 1 to 1 to 462. Okay, so there we go, tongue twister there. So essentially what that does is let's have a look above. It actually essentially what we're going to do is randomly pick out 350 rows, and I just picked 350 myself to be the training data set. Okay, essentially what we're doing is dividing the data into 2. Okay, so for example, all of these cases here are going to be part of my training data set, and I'm going to have another data set called the test data set with the remainder, everything that's not in there. Okay, the other 112 values. Okay, now if you are familiar with Caret, and if you're not familiar with Caret, I strongly suggest you get familiar with Caret sooner rather than later. Okay, so this is another approach that you can take to creating a partition. So there's a package here called Caret. Okay, and just for the sake of reproducibility, so that you can do it the same, or you get the same values I do, I'm going to set a seed here of 3,456, 3456. Okay, so let's run that. There we go. Just give it a second there. That was very quick. So what happens here is I get something very similar to this. This has just been overwritten, but it's the same sort of idea. What happens here is I'm going to split up my data set into 2. I'm going to call it train essay and test essay. So essay being South Africa. Okay. So essentially, I have just pick out the rows that correspond to that did get selected for the training data set, and the minus train index is basically whatever is left. Okay, so just gets split up into 2, partitioned into 2, rows picked out at random and allocated to training and testing respectively. Okay, so in this case what happened here is that 80% got, rather than me picking out 350, 80% have got selected. So it'll be close to 350, but it'll be slightly different. Okay, so those are the 2 data sets being created. So the SA Heart data set has been partitioned in 2. So we have train SA and test SA. Now I'm going to fit the model here, but what I'm going to do first is go back to these notes. Okay, So this is like fit a logistic regression model with coronary heart disease, CHD, as the outcome variable, and the following as predictors: age, alcohol, obesity, tobacco, type A, and LDL. Okay, so what we're going to do here is we're going to try and explain and predict CHD based on age, alcohol, obesity, tobacco, type A, and LDL. Okay, so this is just actually a statement of what gets explained by what. That's all that is. Okay, so what do I need? So this is actually, yeah, so I'll just go back to the notebook here. Okay, so let's fit our model. There we go. That was easy. So GLM, this is our model here. Okay. Now, importantly, what I'm going to do here is I'm going to use the training data set to fit the model. Okay. So there's a big question here as to what is a training data set and what is a testing data set. Okay. So it's too big a question to handle in this video, but essentially it's something to look at as a why you might do it. Okay, to just sort of cross-validation and stuff like that. It's well worth looking into. So I'm not using the entire data set, but what I'm going to do is, with 80% of the data set, I'm going to fit a model, okay, and let's have a look at it there. Let's just fit the model. This is the summary of the model, okay, and this goes into quite a lot of detail, okay. Tells us what is important and what is not important. So alcohol and obesity does not seem to be that important in predicting coronary heart disease. Now, don't jump to any conclusions yet. There's such a thing as multiclinearity, and so you don't get rid of both of them. You might get rid of one, then the other, you know. But anyway, that's a thing called stepwise regression, and that's for another time. Okay. A little bit of stuff there about null deviance and so on, Fisher scoring and so on. Now, this is actually just as a quick aside. What you could do is have a look at a package called Broom. And Broom is one of the tidyverse packages, and it gives us a nice sort of data frame with all the main statistics. Unfortunately, actually, this is one thing I don't like about Broom. It doesn't have the little asterisks beside it to tell us which is important and, well, which is significant and which is not. It doesn't sort of it doesn't give us a big sort of visual cue that I really like. But you can't have everything. Okay. What I mean is these things here, essentially. Okay. So Broom is a package that's well worth looking into, but it's for another time. So essentially, I'll just do the main parts here. The coefficients, these are the regression coefficients. Okay, interesting. But this is the log. This is the odds ratios. Okay, and that is probably the key bit of information that you would interpret. Okay, I find these very useful for interpretation, actually very intuitive when you're trying to sort of explain the model to somebody. What I'm going to do here actually is I'm just going to change that slightly to confident to give us confidence intervals. Okay, and that's actually really handy as well. Okay, you might notice that alcohol and one is in that range of values between. Okay, anyway, that's interpreting confidence intervals, okay? So, what I'm going to do here is actually sort of tell us for each case, what does each outcome give us, okay? Or what is the predicted outcome for each person, okay? Now, so let's have a look at that here. And what happens here is, we essentially get a load of numbers here, okay? And you have to think, what am I looking at here exactly? So essentially, if it's less than 0.5, it's predicting a 0. And if it's greater than 0.5, it's predicting a 1. Okay? It's a little bit hard to interpret, and it's one thing I'm not a fan of. But also, how do you actually use that? Okay, this is where a little bit of a mathematical trick comes into play. Okay? Now, just actually as a remark, if other packages sort of overcome this problem. I'm just working on the basis of the simplistic GLMs, or the straightforward GLM model, R function. Okay. Now, something I'm just going to remark upon here is you can learn some really nice little tricks. So what I could do here is the outcome variable is predict a real number between 0 and 1. If the number is greater than 0.5, it's a yes outcome or a positive outcome. And if the number is less than 0.5, it's a negative outcome. Okay. So what you could do here is to actually, a very quick way of transforming it to zeros and ones is to double the numbers and get the floor function. Okay. So that's how you might sort of convert from like a quick conversion. Okay, just a little remark there. You'll be surprised how useful functions like floor, ceiling, sine, and abs can be for these little data transformations. Okay, they're very useful, and you'd be way more useful than you can ever think. Okay, just loads of stuff you could do with them. Okay, that you think it would take a load of work to do. Nope, those little commands are very useful. Okay, so what I could do here, I'm just going to comment that out because it takes up a lot of space. Let's run that. I'm just going to put the floor function in, or 2 times those values, and get the floor function of that. And we get train, predict. Let's have a look at that there. There we are. A whole bunch of 1s and 0s. Okay. Predict 1, predict 0, yes or no. Okay. Now that's way more useful than the numbers we got earlier on. Okay. Now let's cross-tabulate them. Okay. See how well our model did. Now we had, I can't remember how many we had altogether, but this is what is essentially a confusion matrix. Okay. And we're basing it on the predicted outcomes. Okay, train.predict, and the actual CHD values. Okay, so it's just a simple cross tabulation. Now in the carrot package there is a confusion matrix that should give you a result very similar to that, or almost like that, but just with a few extra values. So that's a confusion matrix. It actually just gives us a quick indication of how many we got right and how many we got wrong. Okay, so we got 199 zero cases correct, we got 65 positive cases correct, and we got 67 false positives and 39 false negatives. Okay, now this is actually sort of just following off my theme there earlier on, that if you want to find out how many you got right, and quick little command there to just actually pick out the diagonal of that table. Okay, so that's actually how many zeros you got right and how many ones you got right. That's a little linear algebra command called diag. It actually just picks out the diagonal values of a little a table. Okay, as long as it's a square matrix, of course. Okay, or that table there actually isn't a matrix really, but it's close enough that it'll do that we can pick out the diagonal. Okay, and we can actually sum that up to see how many we got right. 264. Okay, and we can divide that by the number of rows in train SA. Okay, so well, the number of rows in train SA is probably about 350. I didn't actually check. It should be close to 350, but I did it. I used the carrot package to actually create train SA, so it's 370. So we got 264 out of 370 correct with our model. The model's not great, needs improvement. So now that's the predict for the training data. But what I'm going to do here now is apply to new data. Okay, so the test SA data is, as far as our model is concerned, that is completely unseen. Okay, so this is predict model fit new data equals test SA. Okay, so we're applying a model our model to data that it's never seen before. That's the general idea for dividing your data set up into training data sets and test data sets. Okay, so let's have a look at that now. And what we can do there is get a cross tabulation table of test dot predict and test SA CHD. Okay. Oops, there we go. Not so good. Not so good. 49 false, true negatives correctly identified. 16 positives correctly identified. True positives. We have 12 false positives and 15 false negatives. So it's probably around 70% effective still, which is probably in keeping with the test data set. It's okay, but we want to be doing better than that. Okay, so it'll probably be a little bit less than 70% accuracy. You can go about it the same way. Get the diagonal of that, the sum of the diagonal. That's how many. This is how many we got right. $49 and $16. Sum that up. And we get, what's that, 65, and so on. Okay. So 65 out of n row test SA. 65 out of 92 is, I'm going to just do it by hand here. Just, so 70%. Yeah, that's what I was sort of expecting. Now, just actually, this is sort of a bit of a digression. That's a bit of a Russian dolls there. It's a function inside a function inside a function. Okay, so not a good idea to that's not a good habit to pick up. So what I suggest you do here is find out about a package called Magritter and the pipe operator. Make your code a little bit easier to read and test. Okay, so that's just a sort of closing remark. The Magritter R package, the pipe operator. Okay, so we'll leave it there.